Welcome back. So in this video we'll cover the last two questions for exercise 12.3. This is a question given. ABC is given as a quadrant. Clear? ABC is not the triangle they're talking about. In fact, ABC is this, okay, that you can say. This is a quadrant. Clear? And they have given the radius to be 14 centimeter. You just read the question. And a semicircle with BC. So BC is given, this line that you can see is given as the diameter of the semicircle. So which semicircle? BC is the diameter of this semicircle. Clear? This is the semicircle that we're talking about. Clear? All right. So first, let's write down what is given. Okay. So let's say ABC is a quadrant. Okay. With radius which is equal to 14 centimeter, and BC is the diameter. Okay, so we're asked to find the area of the shaded region. Okay, so in order to understand this question, first thing, it's not easy for us to find this out, so you'll have to do a little bit of thinking. Clear? So first, what I would do is I would actually take this area of a quadrant or a sector. Okay, and then after I find out the area of the sector, what I would do is I would subtract. So this is the area of the sector that is given. Okay, and then I would subtract the triangle which is given to us. So after I subtract this, we will be left only with this part. Okay, clear? And this part is what we need. All right, therefore let's say what is area of a sector? Area of a sector is going to be equal to theta by 360 by r square. We know that theta is going to be 90 degree. Okay, because this ABC is a quadrant. Okay, and a quadrant is always 90 degree, one of the angles. Okay, one angle or the center. This is actually going to be a center. Actually, quadrant is something like this. Okay, 1/4 of a circle. So all this center point, this angle will be 90 degree. So we can take this as 90 degree by 360. There's nothing even about pi, so you can take it as 22 by 7, and radius is going to be 14 centimeter into 14 centimeter. So you can just 7 into 2 is 14. You just cancel it out. 9 into 4 is 36. 2 divides 2 this, and then you can cancel out. So you'll get this. Okay, so you're getting 11 into centimeter into centimeter. Okay, so that's 7 centimeter to centimeter, write it as centimeter square. Clear? Okay, so 11 into 4 probably it's going to be 154, I assume. Okay, yeah, it's going to be 154. So this is equal to 154 centimeter square. Remember, our objective is to find this area. Okay, so let me just call this area B, say O and E. Okay, let me just call that. Clear? I'll just call this BOCE. Now next what we need is we need to find the area of the triangle. So area of, let's say the triangle is ABC, right? The triangle is the area of triangle ABC. So since we know the base and the height, which is both 14 centimeter into 14 centimeter. Okay, you look at this triangle. This is the triangle that we're trying to find. The base is going to be 14 centimeter, and this is the height, right? AB is the height. So that is going to be 14, AC is the height. Okay, so it's going to be 14 into centimeter, or else if you're confused, you can write it as half into the base. Okay, base into height. The base of the triangle is going to be AC, and the height is going to be AB. Okay, and these are both 14 centimeter each, because they are the radius of the given quadrant. So that's going to be 7, and 14 into 7 would be 98 centimeter square. So we need to find the area of this, right? So I'll call this BOCE. Okay, therefore area of BOCE is going to be equal to area of quadrant. Okay, quadrant minus area of triangle ABC. All right, so area of quadrant is, or area of sector. Okay, or sector Okay, this is given as 154 centimeter square minus 98 centimeter square. So that must be 60. Okay, let me just make use of a calculator just to be sure, okay, whether my calculation is correct or not, to verify. So this is going to be 56 centimeter square. Okay, that means it's the area of this. Okay, this is the area. Now, since we're asked to find the shaded portion, what do we do? How do we go about? We're asked to find out, this is, I'm going to call this the semicircle, and this is triangle. Which area? This is B, O, C and E. Okay, so we're just asked to find this area, right? So in order to find this area, all we have to do is we have to take the area of the semicircle and then subtract it with area of BOEC, right? Take the area of a semicircle, subtract this area, then we'll be left with this remaining portion. Clear? And what do we know about BC? Okay, so next thing what we have to find is we actually need to find out what BC is, right? Because we do not know the radius C. AC and AB are the radius for only this quadrant, okay, but not for the semicircle. So we need to find this. We need to find out BC, okay, the diameter. Therefore, this is the triangle given to us. Okay. ABC. Okay. So this is both 14 centimeter. Clear? Now our objective is to find BC, because if you read the question, BC is actually the diameter of the semicircle. So if we know the diameter, it becomes easier for us to know the radius. So since we know that this is also a 90-degree angle, since triangle ABC is a right angle triangle, okay, it's a right angle triangle, we can use Pythagoras theorem, right? We can use Pythagoras theorem. Pythagoras theorem. Okay, so the theorem is going to be hypotenuse square equal to I'll call this the perpendicular, or you can perpendicular or height, okay, and then base square. So this is going to be BC square is going to be equal to 14 centimeters whole thing square plus 14 centimeter whole thing square. So this is going to be BC whole thing square equal to 196 centimeter square plus 196 centimeter square. In fact, what you can do is, okay, 196 would be 3392. Okay, when you add up 196, okay, so this is okay. Or some of you can do this. How many 196 centimeters square you can see? 2 times, right? So you can write 2 into 196 centimeters square. Okay, it's not really a problem. Okay, it's something like this: 3 plus 3. How many times do you see 3? You see 3 2 times, so 2 into 3, and this is the same. Okay, or for example 6 plus 6 or 6 plus 6. How many times do you see 6? 3 times, so 3 into 6, so this is going to be 18. This is going to be the same thing. Clear? So you can add them up, or else you can ease up your work and write this as 2. How many times 196 centimeters square? You see 2 times, right? Okay, so you can go with this, okay, and you can go, but right now I'll be just going with this step. Okay, I've just given you some examples. Okay, or 12 plus 12. Okay, how many times do you see 12? 2 times into 12. So 12 plus 12, you add them up, it is 24. 2 into 12 is also 24. It gives the same answer. Okay, so I'll take square root of this. Okay, so I'll be left with 2 into 196 centimeters square. In fact, 196 is nothing but the square root of 14 square and centimeter square, so you can cancel out the square. Okay, so remember 2 is still there in the square root. Okay, you can only remove 14 and centimeter out, so you'll be left with BC is going to be 14 root 2 centimeters. So BC is actually the diameter. So the diameter of the semicircle, is equal to BC, which is equal to 14 root 2 centimeter. But what we know about diameter is that diameter is nothing but 2r. So this is going to be 14 root 2 centimeters. So this is 2. So r is going to be 7 root 2 centimeters. So this is going to be the radius of the semicircle. Okay, so we have everything that we need actually. Okay, so lastly, let's go area of the shaded region. Clear? Of the shaded region. Clear? So what did I tell you how to find out the area of the shaded region? We had to take the area of the circle and subtract it with the area of, that means BOC. You look at this, we asked to find this, so take area of the semicircle. Okay, now we know anything, we know the radius as well, right? And then subtract it with this area BOCE, which we have already found out to be 56 centimeters square. So area of, this is going to be area of semicircle, okay, minus area of I forgot, BOCE. So area of semicircle is going to be pi r square by 2 minus, this is 56 centimeters square. 56 centimeters square. So pi is 22 by 7 into 2. Radius is given as 7 root 2 into 7 root 2. Okay. Minus 56 centimeters square. So in fact, 7 clear. And don't forget centimeter and centimeter. Okay, I completely forgot. So you're left with 22 into root 2 centimeter into 7 root 2 centimeter, right? Divided by divided by 2 minus 56 centimeters square. So in fact, if you multiply root 2 with root 2, you'll end up getting 2 centimeters. Okay, centimeter square into 7 divided by 2 minus 56 centimeters square. So just cancel out. So this will be 154 centimeters square. Okay, minus 56 centimeters square. So that 154 minus 56 would give you 98 centimeters square. 98 plus 56, 4, 1, yes. Okay, so the area of the region is going to be 98 centimeters square. Now for the last part of this question, it's a very interesting question. Okay, first calculate the area of the designed common between the two quadrants. Now it should be understood, since all these measurements are the same, they are going to be a square, right? Because look, this is 8 centimeter, 8 centimeter, 8 centimeter, 8 centimeter. So it's going to be a square. Now we have to find this area of the shaded region. Okay, clear? So in order to find this, we first have to find, you just look at this. Okay, I'll draw a line here. All right, you just see if you can get this. I'll draw another line here that will equally divide these two designs into two equal parts. Okay, so do I have a chord? Do I have a sector? Yes, this is the sector I'm talking about. Okay, or this, yeah, this is the sector I'm talking about. Clear? See, yes. Okay, and then this is the line that I've drawn. See, okay, this is the line that I've drawn. So now you think about it. Okay, everyone play with this. Okay, so this is the sector that I'm referring to. Okay, this is the sector that I'm talking about. And then I'm just drawing another line here, making it a triangle. Now if I take the area of this sector, okay, this sector, and I subtract the given triangle, okay, from this given sector, I'll be left with this design. Yes or not? Yes. Now similarly, you do it for the other side as well. Okay, it has the same measurement, so it makes our work much more easier. It has the same measurement. So for this part, for the other half, you look carefully. Okay, so we're done with this part. Okay, with this side. Now let's go with the other side. Clear? So if I go with the other side, see, it has the same measurement, so you don't have to worry. This is both 8 and 8. So you look at this. Okay, this is going to be the sector, yes or not? Yes, this is going to be sector, and this is the triangle. So if I take the sector and I remove the triangle, I'll be left with this part. Yes. Okay, I take the sector and I subtract the triangle, I'll be left with this part. So now you carefully look at this. When you do that technique, we end up getting this both areas, right? We end up getting both areas. Yes or not? Okay, so what you can actually do is, clear, and since they have the same measurement, we don't have to do it separately. Okay, clear? So let's start. Okay, given radius, okay, radius between the two corner circles of radius equal to 8 centimeter each. Okay, this is the radius given to us. Clear? See, calculate the area design region in in figure 12.35, which is common between the two quadrants. Okay, so they are common between the two quadrants. So if you actually pay attention to it, see, this is the quadrant, one quadrant, clear? From this to this side is one quadrant, and from this to this side is another quadrant. I'm just repeating over and over again, but I hope you understood the first part. Okay, therefore I'll just directly write area of the shaded region. Okay, area of the designed area. Designed area. Since they have the same length and all of that, so it's going to be 2 into area of quadrant of sector. Okay, I'll call it a sector, and I have to subtract 2 into area of triangle. All right, okay, then you will be able to get the answer. So clear? So if you take 2 into area of sector, it's going to be theta by 360 pi r square minus 2 into half into base into height. Clear? So you can just start cancelling this. 2 and 2 will be gone. Clear? Yeah. So the next step, we get this as 2 into 90 degree divided by 360 into 22 by 7. The radius is given as 8 centimeter into 8 centimeter. Minus, you're only left with the base and the height. And in fact, the base of the triangle, if you look at that, okay, see this is the line. So if we look at this, focus on triangle ABC for now. Okay, so the base is going to be you look, focus. Okay, so this is the triangle I'm talking about, ABC. You see the graph and you see this. Okay, so this is given as 8 centimeter and this is given as 8 centimeter. So definitely the base is 8 centimeter and the height is 8 centimeter. So you can write, in fact, it's going to be the same for both. If you don't agree with me, you consider this triangle again. Okay, I'll call this D. So let us consider the other triangle, which is A, D and C. Even for this case, this is going to be the base, 8 centimeter. Okay, clear? This is the 8 centimeter and 8 centimeter. Okay, and do not get confused, we're talking about a right angle triangle. So this side always has to be the hypotenuse, okay, by any means, by hook or crook. And when we talk about the height of a triangle, so this is going to be the height of a triangle. Okay, so this is going to be 8 centimeter into 8 centimeter. Okay, so you can start cancelling 9 into 4, and you can cancel this 2 and 11. So it's going to be finally you'll be left with 11 into 64 centimeter square by 7 minus 64 centimeter square. Clear? So you can just take 11 into 64 centimeter square minus 64 centimeter square into 7 by 7. Okay, so you can take 64 centimeter square common, so you'll be left with 11 minus 7 divided by 7. So this is going to be 64 centimeter square into 4, right? 7 minus 4. So you just check out how much do you get for 64 into 4. 64 into 4 is equivalent to 256 centimeter square by 7. Okay, so that is the area of the portion that we are asked. Okay, it's area of the designed area. Okay, clear? So maybe you'll have to draw a straight line here. Okay, clear? You just look at this, just focus on this first part. Okay, this is not direct, so you may have to sit and ponder and think a little about it. Okay, clear? So I'll just draw this line here. You just draw this, okay, and then you'll be able to get it. So this is going to be one of the this is going to be one. Okay, I'll just draw with different colors. This is one of them. Clear? I could not draw a straight line, and then I'll draw with yellow color. So this again, you look at this. Okay, the one in red is going to be one quadrant, and the other line that you see in yellow is going to be another quadrant. Okay, I think this is much more better. Okay, with two different colors you'll be able to have a better idea of which are the two chords that we're talking about. Okay, let's see. Okay, so this is what we're talking about. Alright, and in fact let me just draw this line in another color, maybe purple. Okay, so not clearly visible. Okay, but I hope you understand. Okay, so you focus on the red line first and then subtract it with the triangle, so you'll be left with this section. Okay, the first part, you'll be left with this section alone. Now focus on the yellow line. Alright, focus on the yellow line and subtract this given triangle, so you'll be left with this line alone. Okay, so when you add them up, you'll end up getting this purple and this yellow area, so that becomes the design area. Okay, so we'll end this video here.